All the world's a stage, and all the men and women merely players. So begins one of Shakespeare's most famous monologues in his pastoral comedy, As You Like It. The speaker is a cynical and melancholy nobleman who goes on to describe the 7 stages of life, beginning with the mewling and puking of infancy. The last stage is old age, which he describes as second childishness and mere oblivion. This famous, if depressing, characterization of old age reflects the fact that most people during Shakespeare's time believed that a profound deterioration in mental abilities, what the nobleman calls a second childishness, is a natural and perhaps even inevitable part of getting old. And that same belief can be seen in the writings of Pythagoras, Hippocrates, and Aristotle thousands of years earlier. It's even reflected in the etymology of the word senility, which is just based on the Latin word for old man. And the belief that severe mental deterioration is a normal part of aging persists to this day in some circles. But it's wrong. While it's certainly true that many older people do suffer from very serious mental deterioration, scientists today recognize that such mental decline usually reflects some kind of disease process and is not a normal part of aging. And most scientists therefore prefer the term dementia rather than senility in order to de-emphasize the connection with age. Well, in this lecture, we'll explore what dementia is, what causes it, and what we can do about it. We'll talk about different types of dementia, some of the characteristic symptoms associated with dementia, and how we can distinguish dementia from the more subtle cognitive impairments that most of us experience as we age. Then we'll spend the rest of the lecture talking about Alzheimer's disease, which is the single most common cause of dementia in older people. Let's begin by talking about what we mean by dementia and some of the most common causes. Dementia refers to a loss in mental abilities that is severe enough to interfere substantially with normal activities of life. To be diagnosed as dementia, the mental impairment should not have been present from birth, should not be associated with any alteration in consciousness, and should last for more than 6 months. Dementia is usually progressive, meaning that the mental impairments get worse over time. Often the first signs are significant memory problems, like forgetting where you live or the names of close friends and family members. Reasoning abilities may get worse, making it hard to plan activities, perform straightforward computations, or follow the storyline of a book or TV show. People with dementia may also have trouble with language and may find it hard to follow directions or to put thoughts into words. They may become restless, agitated, or disoriented and start behaving inappropriately or even aggressively. They often lose interest in activities that they once enjoyed, and they may become passive or depressed. And ultimately, they may experience hallucinations, paranoid delusions, and personality changes that make them almost unrecognizable to their friends and family. Now, it's important to keep in mind that dementia is different than occasional mental lapses. Most older people experience memory problems from time to time. Perhaps they forget where they put their glasses or their keys, or they forget where they parked their car. Maybe they neglect to make one of their monthly payments or have trouble remembering a specific word or an acquaintance's name. Many people experience problems like these as they age, and they aren't normally a cause for concern. However, if the mental lapses get severe enough to disrupt daily life, then it might be the beginnings of dementia. For example, temporarily forgetting the word for toothbrush probably doesn't indicate a problem, but forgetting what a toothbrush is for might. Warning signs include symptoms like asking for the same information over and over, finding it really hard to complete mental tasks that used to be easy, or forgetting what season it is. Other early symptoms could include getting lost in a very familiar environment, having trouble carrying on a simple conversation, or failing to take care of basic personal hygiene. Significant changes in personality or mood are also potential warning signs. So if you notice symptoms like these in yourself or in those around you, then it's worth consulting with a doctor. There are actually a variety of different types and causes of dementia. Some types are reversible and will improve if the underlying condition is treated. For example, depression can occasionally produce dementia-like symptoms, and those symptoms will often improve if the depression is treated. Other potentially treatable causes include a vitamin B12 deficiency and Lyme disease. Even commonly prescribed medications can produce symptoms associated with dementia. For example, memory loss is a very common side effect of benzodiazepines, which include anti-anxiety drugs like Xanax, Ativan, and Valium. Opioid painkillers like Vicodin and Percocet can also lead to dementia-like memory problems. So can beta blockers, which are sometimes prescribed in the treatment of heart disease and high blood pressure. The bottom line is that dementia-like symptoms can be the result of a treatable condition or reflect a side effect of a medication that's being taken for a different purpose. And these symptoms can often be reversed by treating the underlying condition or by switching to a different medication. So, if you notice dementia-like symptoms in yourself or in a loved one, be sure to see a doctor. But dementia can also be caused by brain diseases. For example, over 50% of patients with Parkinson's disease eventually develop symptoms of dementia, although it typically takes about 10 years after the onset of Parkinson's for such symptoms to appear. Progressive loss of neurons in the frontal and temporal cortex can also produce a dementia called Pick's disease or frontotemporal dementia. This disorder is characterized by significant personality changes, by apathy, and by problems understanding and producing language. One fairly common type of dementia in older people is vascular dementia, or what's sometimes called multi-infarct dementia. An infarct is a localized area of tissue that dies because of a lack of oxygen. And when this happens in the brain, it's called a stroke. Now, as we'll discuss in detail in our next lecture, the victim of a major stroke may experience weakness or paralysis on one side of the body. They may also exhibit abnormal speech, particularly if the stroke involves the brain's left hemisphere, which controls spoken language in most right-handed people. But it's also possible to experience minor strokes that only affect a very small part of the brain and that don't lead to any outward symptoms at all. In fact, the victim may not even be aware that they've had a stroke. And these so-called silent strokes are probably much more common than major strokes that produce significant symptoms. Furthermore, silent strokes do produce infarcts, that is, localized brain damage. And if someone experiences multiple infarcts, the accumulation of brain damage can lead to dementia. And that's why it's often called multi-infarct dementia. But by far the most common cause of dementia is Alzheimer's disease. In fact, Alzheimer's disease accounts for 50 to 75% of cases of late-life dementia. So I want to spend the rest of this lecture talking about this devastating disease, how it progresses, and steps you can take to reduce your risk, as well as research aimed at understanding the underlying mechanisms and at finding a cure. Alzheimer's disease was named after Dr. Alois Alzheimer, a German psychiatrist who identified the first published case in a mental hospital in Frankfurt. On November 25, 1901, a railway worker named Karl Dieter brought his wife, August, to the hospital because she was becoming demented. Her memory was failing. She was often delusional, and she would scream for hours in the middle of the night while dragging sheets around the house. When questioned, she would often say, "I've lost myself." Dr. Alzheimer's notes about this case survive to this day. Here's an excerpt. She sits on the bed with a helpless expression. "What is your name?" "August." "What is your husband's name?" "August." "What is this?" I show her a pencil. "A pen." Now, Dr. Alzheimer goes on to describe his patient forgetting about objects she was just shown a few minutes before, and misidentifying cauliflower and pork as spinach, as well as being unable to write her complete name. Now, that excerpt provides a classic picture of what dementia is like. And as a psychiatrist, it's a picture that Alzheimer had undoubtedly seen many times before. But what interested him about Frau Dieter's case was her age. She was only 51 years old. And remember, in 1900, even doctors thought that dementia was a result of aging. So why would someone develop dementia at age 51? Well, Alzheimer followed her case closely for the next 5 years. And after she died in 1906, he carefully examined her brain. And when he looked at her brain under a microscope, Alzheimer found 2 significant abnormalities that are now considered to be the defining features of Alzheimer's disease. First, he found unusual clumps between neurons that turned out to be composed largely of protein fragments called amyloid beta. These clumps are now referred to as amyloid plaques. He also found neurofibrillary tangles. And when scientists started examining the brains of other patients who had been demented before they died, they found these same kinds of plaques and tangles in many of them. In fact, finding these microscopic abnormalities in patients who had dementia is the only way Alzheimer's disease can be definitively diagnosed. Physicians and scientists can often be fairly confident of an Alzheimer's diagnosis based on behavioral symptoms and the patient's history and brain scans, but they can never know for sure until they look at the brain with a microscope after autopsy. And that's why they often refer to their diagnosis as dementia of the Alzheimer's type, or as probable Alzheimer's disease. Alzheimer's disease progresses at different rates in different people, but no treatments have yet been found that can slow or halt the disease. It usually has a late onset, meaning that it's diagnosed after age 65. And when it's diagnosed before age 65, it's referred to as early onset, but that's much less common. On average, people live about 4 to 8 years after their initial diagnosis, although some patients live significantly longer. Now, in order to understand the progression of the disease, it's helpful to understand how it affects the brain and how those effects grow over time. The symptoms of Alzheimer's usually start to appear many years after the plaques and tangles associated with the disease start affecting the brain, sometimes even decades after. And this period of time after the onset of the disease, but before the appearance of behavioral symptoms, is sometimes referred to as preclinical Alzheimer's disease. But as the plaques and tangles multiply, neurons begin to die, and connections between neurons stop working. And the first brain area where these effects are observed is usually the hippocampus and nearby structures in the medial temporal lobes. We actually talked about the hippocampus and the medial temporal lobes in Lecture 4, when we talked about some of the structural brain changes associated with normal aging. We pointed out that white matter deteriorates and that the prefrontal cortex and hippocampus shrink as we get older. And furthermore, we explained that the hippocampus plays a crucial role in episodic memory, which may explain why episodic memory tends to get worse as we age. Okay, now imagine that in addition to normal age-related shrinkage of the hippocampus, you've also got the accumulation of plaques and tangles and the associated death of neurons. What would you expect the result to be? Well, the result is significant problems with memory. In fact, memory problems are often the first sign of Alzheimer's disease. Victims begin to have substantial problems coming up with the right word or right name, just like August Dieter misnamed a pencil as a pen. They might start forgetting people's names, sometimes even for people they know quite well. They might have a hard time reading or following a movie because they forget what they've just read or watched. Likewise, they might start losing or misplacing objects a lot more frequently than other people their age. As the disease progresses, the plaques and tangles begin to appear in other brain regions outside the hippocampus, including parts of the cerebral cortex. And as the disease spreads in the brain, the behavioral impairments also expand. Now recall that the cerebral cortex is that sheet of gray matter on the outside of the brain, like the bark on the outside of a tree. Some of the parts of cerebral cortex are devoted to processing specific senses. These parts of cortex are called the primary sensory cortices. For example, the cortex at the very back of the brain is devoted to vision, and it's called the primary visual cortex. Likewise, some of the cortex beneath your ears is devoted to hearing, and it's called the primary auditory cortex. You also have primary somatosensory cortex, which is devoted to touch, and primary motor cortex, which is devoted to motor control. But other parts of your cerebral cortex outside the primary sensory and motor cortices are devoted to higher cognitive functions. And these are the so-called association cortices. And they're often among the first regions outside the hippocampus to exhibit damage in Alzheimer's disease. And as these areas fall prey to the effects of the disease, so too do the higher cognitive functions that they support. So patients might begin to have trouble with planning and problem solving, even though they can still see and hear and walk around. They'll typically have a hard time with calculations and with mental tasks like balancing a checkbook or planning a meal. Their language skills might also deteriorate, and they'll begin using words in the wrong way or substituting incorrect sounds for words. They'll often feel confused and restless, particularly when the sun is setting for some reason, a phenomenon that's referred to as sundowning. Their sleep patterns might get disrupted, making it difficult for them to sleep at night. Patients might also begin to show personality changes like paranoia or unexplained bursts of anger, sadness, or fear. Still others might remain relatively docile. And of course, the original memory problems will also be getting worse. Patients will start forgetting their own personal history, like where they went to school or how they met their spouse. They'll often be confused about where they are or what day or even what year it is. They might also wander away and get lost, even in a very familiar environment like their own neighborhood. Ultimately, the disease spreads to many other areas of the brain, and it begins to affect almost every aspect of behavior. Patients in the final stages have difficulty doing almost anything for themselves, and they need around-the-clock care. They may only be able to use a few words or phrases, and communication becomes very difficult. Motor skills deteriorate, and they ultimately become bedridden and unable to feed themselves. Now, obviously, Alzheimer's disease is an absolutely devastating illness, and not only for the patient, but also for the people around them who take on the Herculean task of caring for someone suffering from this horrible disease. So, is there anything we can do about it? Well, yes and no. There's currently no cure. Worse yet, no treatments have been shown to delay the progression of the disease. There are, however, some palliative treatments that help relieve some of the symptoms as the disease develops. For example, the drug donepezil is often prescribed, especially during the early and middle stages of the disease. Donepezil inhibits the breakdown of the neurotransmitter acetylcholine, and therefore tends to increase the levels of this neurotransmitter in the brain. Now, acetylcholine is a crucial neurotransmitter in the motor system, in the hippocampus, and in the cerebral cortex, and it plays an important role in memory, in attention, in sleep, and in mood. Furthermore, Alzheimer's disease causes acetylcholine levels to drop, which may contribute to some of the behavioral deficits in these functions. So drugs like donepezil can therefore temporarily relieve some of these symptoms by boosting acetylcholine levels. Another commonly prescribed drug is called memantine. This drug works by reducing the activity of the excitatory neurotransmitter glutamate in the brain. Too much glutamate activity can sometimes lead to neuron death in a process called excitotoxicity. And so scientists decided to try memantine in order to reduce glutamate activity. And they found that it did improve cognitive function in some moderate to severe Alzheimer's patients. Again, it's not a cure, and it doesn't work for everyone, but it does often help and is therefore commonly prescribed in the moderate and severe stages of the disease. What about avoiding Alzheimer's disease? Is there anything we can do to reduce our risk of contracting this terrible illness? Well, first, it's important to point out that both genetic factors and environmental factors influence risk. Most studies suggest that genetic factors may actually be more important. In fact, some genetic variants virtually guarantee that a person will develop Alzheimer's disease early in life, like in their 40s or 50s. But it turns out these variants are very, very rare. A much more common genetic factor is the so-called ApoE gene. This gene encodes the information necessary to make apolipoprotein E, which influences how likely it is for amyloid plaques to form. In particular, 40 to 80% of people with Alzheimer's disease carry at least one copy of the E4 version of this gene. And if you carry 2 copies of that version, you're more than 10 times more likely to contract the disease late in life. Now, obviously, there's nothing you can do about genetic risk factors. But are there any non-genetic factors over which we do have some control? Yes, there are. There are no guarantees, but research has shown that a number of behavioral changes can reduce the risk of contracting Alzheimer's disease. And most of these can be summarized in 2 pieces of advice. First, stay active. And second, eat right. These 2 pieces of advice are actually important for everyone as they get older, even people who won't ever develop Alzheimer's. And in lectures 10 and 11, we'll be talking a lot about strategies that we can all exploit in order to age as gracefully as possible. And staying active and eating right will be 2 of the most important topics we discuss. So we'll go into a lot more depth then. But for now, let me just summarize some of the science exploring the relationship between activity and diet on the one hand and the development of Alzheimer's disease on the other. In 2005, Mia Kivipelto and Suvi Rovio at the Karolinska Institute in Stockholm, along with a number of their colleagues, examined the relationship between leisure time physical activity during middle age and the subsequent development of Alzheimer's disease. Now, in this study, middle-aged people were classified as physically active if they participated at least twice a week in an activity that causes breathlessness and sweating and lasts 20 minutes or more. People who didn't participate in such activities at least twice a week were classified as sedentary. And these same people were then evaluated for Alzheimer's disease over 20 years later, after they passed the age of 65. They found that 4 to 5% of the people who were sedentary during middle age developed Alzheimer's disease, while only 2% of the people who were active did. Put another way, the sedentary people were more than twice as likely to develop Alzheimer's disease compared with the active group. And similar results have now been reported for people who regularly engage in cognitive and social activities. Eating a healthy diet has also been associated with reduced risk of Alzheimer's disease. A number of studies have found that eating a lot of fruits and vegetables, especially green leafy vegetables, can reduce your risk. Omega-3 fatty acids, which are found in salmon and certain other fish, have also been found to reduce the accumulation of amyloid plaques in experimental animals and may therefore reduce the risk of developing Alzheimer's. These foods are featured prominently in the so-called Mediterranean diet. And sure enough, a study out of Columbia University found that people who eat a Mediterranean diet are less likely to develop Alzheimer's disease than other people. Furthermore, people eating diets like these are less likely to be obese and are also less likely to develop diabetes, both of which significantly increase risk for Alzheimer's disease. Now, of course, most of the Alzheimer's studies investigating diet and activity are correlational. That is, physical activity and healthy diet are correlated with reduced risk. But as we've discussed before, correlation does not imply causation. And so we can't say with certainty that diet and exercise cause a reduction in risk. Nevertheless, it seems quite plausible that they could help. After all, exercising and eating right are known to improve our cardiovascular health. And since our cardiovascular system supplies our brain with blood and nutrients, it seems likely that what's good for one would also be good for the other. Finally, let's talk about the current status of research aimed at finding a cure for Alzheimer's. Have we made any progress in understanding the biological mechanisms underlying this disease? And if so, do they suggest any ways to fight Alzheimer's and maybe even cure it? Well, although there's still substantial debate about the key biological mechanisms that lead to Alzheimer's disease, most researchers today believe that the accumulation of amyloid plaques initiates a cascade of molecular events that lead to the appearance of neurofibrillary tangles within cells, to compromised neural function in the hippocampus and association cortices, and ultimately to Alzheimer's disease. And this so-called amyloid cascade hypothesis has led to a number of promising directions to pursue to try to stop the disease. One idea is to try to slow down the accumulation of amyloid plaques. Now, the core of these plaques is composed of protein fragments called amyloid beta. And these amyloid beta fragments are part of a much longer protein, but they only accumulate into plaques when they get snipped off into shorter fragments. And there are two enzymes that do the snipping: beta secretase and gamma secretase. So many scientists are exploring ways to inhibit these enzymes in the hopes of preventing the formation of amyloid beta fragments and thereby reducing the level of amyloid plaques. Well, it turns out that the gamma secretase enzyme is important in other biological pathways, and so inhibiting its action can lead to significant side effects. And scientists have therefore tried to develop drugs that selectively interfere with the enzyme's role in snipping off amyloid beta without affecting its other biological functions. And one such drug, called fluorazane, showed some initial promise. But unfortunately, larger clinical trials didn't pan out as hoped. So the search continues. More promising is the research on inhibiting beta secretase, the other enzyme involved in snipping off amyloid beta. Now, unlike gamma secretase, beta secretase doesn't seem to play a critical role in other biological pathways. For example, mice that have been genetically engineered to lack the enzyme entirely don't exhibit any major side effects. And furthermore, early clinical trials have found that beta secretase inhibitors significantly reduce amyloid beta levels in cerebrospinal fluid, and they're well tolerated by patients. Now, there are still some important open questions, however. For example, do these drugs have significant side effects that haven't yet been discovered? Another critical question is whether these drugs will actually stop the progression of Alzheimer's disease. I mean, if the amyloid cascade hypothesis is correct, then it seems likely that they will, but we actually don't know that yet. And finally, even if they do stop the progression of the disease, is there any way to get rid of the plaques and tangles that have already developed? I mean, after all, inhibiting the enzyme is only expected to slow the production of new amyloid beta fragments, but it isn't expected to influence the fragments that have already been made. So, beta secretase inhibitors are likely to be better at preventing Alzheimer's disease rather than treating it after it has already developed. Another very promising approach is called immunotherapy. The basic idea is to try to use a person's own immune system to attack the amyloid plaques. For example, in 1999, Dale Schenk and his colleagues at Elon Corporation showed that injecting amyloid beta fragments into mice triggered their immune system to attack amyloid plaques. The immune system itself prevented the development of plaques in young mice, and it actually cleared away plaques from the brains of older mice. The mice also exhibited improvements in learning and memory. Unfortunately, clinical trials in humans had to be stopped when a small percentage of the participants developed encephalitis, or an inflammation of the brain, because of an overly aggressive immune response. So some researchers are now trying an alternative passive immunization strategy, in which antibodies produced in mouse cells are injected rather than amyloid beta itself. Clinical trials are now underway to test this approach. And these are just a few of the many, many approaches that scientists are exploring in their efforts to fight this disease. And although we don't yet have a cure, there's now much more optimism about the possibility of finding one. And I'm therefore cautiously optimistic that future generations won't have to deal with this devastating disease. Okay, let's wrap up. In this lecture, we learned a lot about what dementia is, what causes it, and what we can do about it. We learned that there are different kinds of dementia, some of which are treatable. And we spent most of our time talking about Alzheimer's disease, including how it progresses, how diet and exercise can reduce your risk, and how research into the underlying mechanisms raises hope that we may find a cure in time for the next generation. But Alzheimer's disease isn't the only brain disease that tends to attack late in life. And in our next lecture, I want to discuss two others: Parkinson's disease and stroke. And as we'll see, science has also made substantial progress in understanding these diseases. And that understanding holds real promise for how they'll be treated in the future. See you then.